Welcome to the channel. Today we have a very special topic to discuss, and that is the extraction of gold from process sheet to feasibility. And this is part one. There is a long way to go from preparation of feasibility, preparation of process sheet, and to ultimate project feasibility. Our objective is to prepare technical and financial feasibility based on cyanide leaching gold extraction process. There are many other processes we shall be explaining in due course of time, but we have selected cyanide leaching, that is CIL gold extraction process. And we shall discuss its merits and demerits too. And the project feasibility will be based on grade of ore found in Pakistan, and that is in Rekodek, Balochistan. The most prominent gold deposit in Pakistan is Rekodek in Balochistan, along with Sandek and northern alluvial regions like Gilgit and Baltistan. This is our video number 97. And if you like our efforts, please do like, share, and subscribe to the channel. Let's come to the gold ore in Pakistan. In Pakistan, the gold ore is not found in just one place. It occurs in several mineralized regions, and here are the most important ones. At the top of it, it is Regodek. It is located in Balochistan Chari district, one of the largest gold copper deposit in the world, major focus for modern mining projects. The second important location is Sandik. This is also in Chari, Balochistan, produces copper with gold as a byproduct already in operational mining project. Number three is Kohistan. This is in KPK, gold found in yellow, vile, and hard rock deposits. Includes areas like Indus River Belt. Then at the fourth number is Gilgit Baltistan, gold present in river sediments, that is alluvial gold, and a small scale mining is common. Last but not the least is Noshki, and again in Balochistan. The gold reserves are reported less developed as compared to Rekodek. Most prominent gold deposit in Pakistan is Rekodek, that's in Balochistan, along with Sandak and northern alluvial regions like Gilgit and Baltistan. Here in Pakistan map, you can see the gold ore reserves in Pakistan. Here is Rekodek, that is number one, and then we have number two, that is Sandik nearby, and then number three, this is Noshi. All the three locations are in Balochistan. At the fourth number is Kohistan, that is in KPK, and at the fifth number is Gilgit and Balochistan. Let us start with a process sheet. Process sheet for the extraction of gold ore from raw ore. It follows the common industrial method like cyanide leaching. That is CIL. This is very common, most modern technology-based project. This is a process sheet, which is the most modern used. Alternative to this leaching, there are other methods also, that is gravity separation, flotation, or bioleaching to extract gold from the raw ore. Our project objective is to extract element gold from raw ore and converted into a purified metallic form suitable for further refining or commercial use. The input, that is, the raw material, is gold bearing ore, that is, hard rock or alluvial. Common associated materials, also known as quartz, pyrites, and arsenopyrite, etc. Alluvial, this refers to gold found in riverbeds or sediments, that is, in sand and gravel. Formed by natural erosion of rocks, gold is usually free and coarse, easily removed by gravity method. The other inputs, the other forms of the gold ore are, that is, the in quartz, a very common hard material, silicon oxide, in which gold is often found. Gold occurs in quartz veins inside rocks, requires crushing and grinding to extract gold. As far as the third form of the ore is concerned, it is arsenopyrite. This is a sulfide mineral containing iron, arsenic, and sulfur. Gold is often inside it, called a refractory ore. Requires a pre-treatment, for example, flotation or oxidation before cyanide leaching. Therefore, the one-line summary is alluvial, that is river gold ore, quartz, host rock, and arsenopyrite, sulfide or trapped, sulfide or trapping gold. As the equipments and tools required for the extraction of gold, the list is the general list is as follows. We need a jaw crusher, ball mills, classifier, agitator tanks, cyanide leaching tanks, activated carbon column for CIL. For in this case, there are two processes, CIP and CIL, which we shall explain later. For our purpose, we shall be following CIL. 7. Filter press or vacuum filter, electro-winning cell or zinc precipitation setup. We shall be following electro-winning cell in our feasibility. Furnace for smelting and personal protective equipments. Ball mill referred here is a rotating cylindrical grinding machine filled with steel bars. Its purpose is fine grinding of crushed ore into slurry, that is powder plus water. It is important because it increases surface area so gold can be chemically extracted efficiently. The overall process sheet to extract gold is as follows. Process number 1, crushing. Then number 2, grinding. Then at number 3 is classification. At fourth is leaching. This is the central process to extract gold. And then sulfide solid liquid separation, adsorption CIL or CIP, elution, and then electrowinning oblique zinc precipitation and smelting. And the final process is optional, that is refining to the high purity gold of 99.96%. Let us explain step by step this process sheet. Number 1 is crushing. Ore is crushed using a jaw crusher to reduce size for further processing. Jaw crusher is a primary crushing machine with two plates, one fixed and one moving. Purpose is break large ore rocks into smaller pieces first step before grinding. The crushed ore is then forwarded to the second process, that is grinding. Crushed ore is ground to fine particles using a ball mill. Ball mill is a rotating cylindrical grinding machine filled with steel balls. Its purpose is fine grinding of crushed ore into slurry, that is powder plus water. It is important because it increases the surface area so gold can be chemically extracted efficiently. The third step is classification. This ground ore is passed through cyclones or classifiers to separate the fine particles to particles suitable for leaching. The cyclones are classifiers, the equipment used for particle size separation. That is, here use centrifugal force to separate fine and coarse particles. Fine particles go through next process, that is leaching, whereas coarse particles are returned to ball mill for further grinding. Coming to the step number 4, and this is called leaching. This is the key process. Fine ore are mixed with a dilute sodium cyanide solution in agitated tanks. Oxygen is also added to enhance and dissolve reaction. Chemical reaction takes place, that is 4Au plus 8NaCN, that is sodium cyanide, plus oxygen plus water, which converts to sodium AuCN2 plus 4 sodium hydroxide. Now, what is happening in this step? Cyanide leaching. Fine ore, often crushed and grinding, is mixed with dilute sodium cyanide, that is NaCN, in large agitated tanks. Then, air or pure oxygen is injected to speed up the chemical reaction. This step dissolves gold from the solid ore into a liquid form. And here is the chemical equation which adequately explains the chemical reaction. In simple terms, gold, that is Au, it reacts with sodium cyanide, oxygen, and water. It forms sodium gold cyanide complex. This is soluble compound, so gold moves into solution. Sodium hydroxide makes the solution alkaline. Remember, this is the key process of gold extraction. This process is adequately explained here. Fine ore dilute added with the sodium cyanide solution along with oxygen is added and the gold dissolves into the solution. That is the chemical reaction through the chemical reaction which is already explained, resulting thereby solid gold in ore or Au become dissolved gold in solution. The same can be explained in this infographic too. Cyanide leaching process for gold extraction. We have fine ground ore, then it's mixed with sodium cyanide, sodium dilute, sodium cyanide solution. Then agitation and oxygen is injected. Then chemical reaction takes place and gold dissolves into the solution in the environment which is alkaline environment, and the pregnant solution is now ready for further processing to extract gold. Process. is very, very important. So let us explain in further detail. Solid gold in ore, then we have sodium cyanide, oxygen and water which are injected. Gold dissolves, that is, gold cyanide solution is formed. Key highlights is sodium cyanide dissolves gold, oxygen is essential accelerator, agitation in the tanks ensure proper mixing, and recovers gold form in the liquid form with alkaline environment through the production of sodium hydroxide. Sodium, what is NaAuCN2? It can be called as sodium cyanoaurate. It's a water solution gold cyanide complex formed when gold reacts with cyanide in the presence of oxygen. During cyanide leaching, gold dissolves according to this chemical equation. Significance in gold extraction after cyanide leaching processes, it converts solid gold to solution form, allow gold to move into solution phase, and enables recovery by adsorption on carbon through CIL or CIP processing, and finally through the process of electrowinning. This stage converts gold from solid ore into a recoverable liquid form using cyanide and oxygen. Key points to understand are gold does not dissolve easily in most chemical, but cyanide plus oxygen makes it possible. Oxygen is essential. Without it, the reaction is very slow or may not proceed properly. The product is what later gets recovered using carbon adsorption through CIP or CIL process. These steps convert solid gold in ore to dissolved gold in solution using cyanide and oxygen in simple terms. So, cyanide leaching process of gold extraction can be further explained as follows. Fine ground ore, then mixing with dilute sodium cyanide added in the tanks, and then agitation, that is mechanical stirring, ensure contact. Air and oxygen supplied to enhance reaction. Chemical reaction takes place. Formation of gold cyanide complex takes place, and solid gold is converted to liquid phase. In this chemical equation, it is shown that sodium hydroxide is also produced. It stabilizes the process. Gold-bearing solution is available for the next step, that is CIP or CIL. In the above chart, the number 9, we shall just follow CIL for our project financial feasibility rather than to follow CIP, and we shall explain both these terms in the next few slides. Now, what is the difference between CIP and CIL? CIL is cyanide. This is the key process is cyanide leaching, but carbon in CIL is carbon in leach and CIP is carbon in pulp. In CIL, leaching and adsorption happen together in the same ink. Gold dissolves and immediately adsorbs onto the carbon, faster and more efficient. Fewer stages are required. Adsorption. Adsorption means the gold sticks with the activated carbon on the upper surface, not into the activated carbon. Version CIP, carbon is pulp, carbon in pulp, leaching and adsorption happen separately. Gold is leached into solution. Carbon is added in a separate tank to adsorb gold. We shall be following CIL in our project feasibility. Key difference between CIL and CIP is process CIL is combined, whereas in CIP it is separate. Speed CIL speed is faster and CIP is lower. Efficiency CIL is higher in efficiency, whereas CIP is slightly lower. CIL is suitable for smaller plants and CIP is suitable for much larger plants. CIL combines leaching and adsorption in one step, while CIP performs them in two separate stages. With this, we conclude our discussion on today's topic, that is extraction of gold from process sheet to feasibility. And this is part number one. Please keep in touch, stay tuned to see further videos until we complete project feasibility as completed. If you have yet not subscribed the channel, please do like, share, and subscribe as soon as possible. Thank you and thank you very much.